In this lecture, we solve an important problem of differential equation. And this differential equation, clearly it is linear with constant coefficient but not homogeneous. Okay, that is non-homogeneous, linear with constant coefficient and higher order also. And we know that to solve this type of differential equation, we get two parts of the solution or the general solution. And we write the general solution as y, this is equal to yc plus yp. And this yc is said to be complementary function and this yp is said to be particular integral. Okay. Now we discuss how to find out complementary function and how to find out particular integral one by one. To find the complementary function, that is to solve the homogeneous part, we first let y, this is equal to c into e to the power mx be a trial solution of 1. Okay, let this is 1. Then auxiliary equation is given by, here we put m in place of d, then we get auxiliary equation. This is m square plus 4 whole square into m minus 2 whole square. This is equal to 0. So we get the value of m, which are m, this is equal to plus minus 2y and again plus minus 2y because this is square, and 2. Okay. Now we write the complementary function, this is yc, for the first two equal real root. This is c1 plus c2x into e to the power 2x. For this 2 and 2, these two are repeated root, repeated 2 times, and these are real. And for two repeated complex root, we get the solution as, this is c3 plus c4x into cos 2x plus c5 plus c6x into sin 2x. Okay, and this is the complementary part or complementary function of the general solution. Now we discuss about the particular integral. Particular integral, this is yp, is defined by 1 by f of d into x. Here f of d, this means the function of d, and x means right hand side expression. Okay, so we write here yp, this is 1 by d square plus 4 whole square into d minus 2 whole square into cos square x. But there is no rule to find out the particular integral if this is at any power of trigonometric function. Okay, so we write that this is into half and this is into 2, and we write 2 cos square x. The formula of 2 cos square x we write in this line. This is 1 plus cos 2x. Okay, so we divide it into two portions. The first portion is half into 1 by d square plus 4 whole square into d minus 2 whole square, 1 for the first portion, and for the second portion this is half into 1 by d square plus 4 whole square into d minus 2 whole square into cos 2x. Okay, now for the first portion we take common 4 and take common 2 also. From here and here we get, this is 16, this is 4, because this is square and this is also square, and the expression can be written in the form as 1 plus d square by 4 whole to the power minus 2, and this is 1 minus d by 2 whole to the power minus 2 into 1. And clearly if we expand these two line or these two infinite expansion by the formula of infinite series, then we get only the value is 1, because the derivative of 1 is 0 for all order. So we write directly this is given by 128 into 1. So the first portion is 128. Okay. Now we write the second part. This is given by 2 into d square plus 4 whole square, and if we expand this is d square minus 4d plus 4 into cos 2x. Okay. Now we use the formula of particular integration. Here we write already, if there be sin x or cos x, and if we put minus square in place of d square, and if f of minus square is not 0, then we can put this, but if this is 0, then we cannot put minus square in place of d square. Here if we put d square equal to minus 4, because here a equal to 2, so this is not 0, this factor is not 0, but if we put here d square equal to minus square, then this factor is 0. So we cannot put d square equal to minus 4 here, but we can put here d square equal to minus 4. So we put in the second factor, first factor remains same, and the second factor becomes minus 4d plus 4 into, we again write cos 2x here, and this is minus 4 and plus 4 cancel out, so the result is 128 plus, this is given by minus 1 by, this is 8 into, here minus 4 is present, so minus 4 into 2, this is minus 8, and we take common here 4, that is we get 16. Okay, and this term is, sorry, we cannot take common any one from here, we write this is the remains same as the above line, and we get the result as this. Okay, now we get 1 by 128 minus 1 by 8 into d square plus 4 whole square, 1 by d into cos 2x, and this is given by 1 by d into cos 2x. This means integration cos 2x dx. This is the reverse of derivative. Okay, and clearly this result is minus sin 2x by 2. Okay, so we get this is plus, and this is 16 because here 2, and this becomes sin 2x. But if we put again d square equal to minus 4, then this is 0. Okay, so we apply here a separate rule to find out this type of particular integration, and for this we let this is u, this is 1 by d square plus 4 whole square into sin 2x, and let p, this is equal to 1 by d square plus 4 whole square cos 2x. So we get p plus iq. Okay, and this is given by d square plus 4 whole square cos 2x plus I sin 2x, and we know that cos theta plus I sin 2 theta, this is e to the power I theta. This is the Euler form of complex number. So we put the value of this is e to the power I 2ix. Okay, now we apply this rule of particular integration, 1 by f of d into e to the power ax. If we put d equal to a, and if f of a not equal to 0, then we can put this result, and if this is 0, then we get, if f of a equal to 0, then we get e to the power ax into 1 by f of d plus a, that is we replace d by d plus a. Here if we put d equal to 2i, then this is 0, because 2i whole square, this is minus 4, here a equal to 2i for this case. So here we apply the second part, this is given by e to the power 2ix into 1 by d plus 2i whole square plus 4, and this square and 1 becomes there. So we get e to the power 2ix into 1 by, this is by expanding d square plus 4id minus 4 plus 4 whole square 1, and getting the result e to the power 2ix 1 by, this is 4 minus 4 plus 4 cancel out, and we take common 4id from here. This is 16 I square d square, and the remaining term are 1 plus d by 4i whole square. This is 1. Okay, so we get e to the power 2ix into 1 by, this is minus 16 because 16 I square, and this is given by d square, and we write 1 plus d by 4i whole to the power minus 2 into 1. Okay, again we get 1 from here because the derivative of 1 is 0. So we get the result e to the power 2ix into minus 1 by 16 into 1 by d square. This is given by 1. Okay, so 1 by d square 1, this means 1 by d square 1, this means this is integration 1 by d into integration dx. This is the work of 1 by d, and again this is the integration of x dx, because this integration is x, so we get this is x square by 2. Okay, so the result becomes e to the power 2ix into x square by minus 30, because there is minus 16 and 2 we get here. This result we get finally. Now if we write here minus 1 by 32 into x square into e to the power ix, this means cos 2x plus I sin 2x. Okay, so our imaginary part, we require only imaginary part again q, this is equal to minus x square sin 2x by 32. Okay, so we get 1 by 128 plus 1 by 16 into, this is given by minus x square sin 2x by 32. Sorry, I make a small mistake here. This integration is not negative, this is positive, because integration cos 2x dx, this is sin 2x by 2. So we get here in negative sign. Here a negative sign is present, so this is also negative. Okay, so final answer we get, this is 1 by 128 plus, this is 16 into 32, I think this is 1 by 512 into x square sin 2x. Okay, and this is yt. So this is the second portion of the general solution, and this is the first portion. So we write the general solution y, this is given by, we write the first yc here, that is c1 plus c2x into e to the power 2x plus c3 plus c4x into cos 2x plus c5 plus c6x into sin 2x plus 1 by 128 plus 1 by 512 x square sin 2x. Okay, this is the general solution of the problem. This is very important type problem, and this is also very important for your university exam. Thank you for watching.